Okay. Let's talk about the fully differential amplifier with capacitors. Yes, we have a fully differential amplifier here. We can use this fully differential amplifier as for amplifier. I can put something like this kind of resistor. Then I have my differential input voltage here. I have my differential output voltage there. Yeah, if I assume this arrow is pretty small, arrow is very, very small. I mean, arrow is much smaller than R2, okay? Then, yeah, so my differential output voltage will be however, in our case, this arrow is pretty large. This arrow may be very large, like 10 mega or more, something like that. I'm not sure exactly. Very large. So if you put some resistors there, that resistor by voltage gain will be reduced, right? GM times that arrow thing parallel R2, something like that, right? Because of this arrow, my voltage gain will be dropped. So I use a capacitor instead of a resistor, like that. Okay? So this part is my fully differential amplifier. Oh, no, not the one. Sorry.
R가 굉장히 크면요. 그게 그냥 거의 오픈이어서 오픈이 불로 돌려고 안 하니까 그 개인이 안 주는 거 아니에요?
Okay, so your question was if my arrow is pretty large, I mean very large. Question is if arrow is very large, what happens? Okay? So this voltage gain will be dropped. There will be large gain error. Gain error. So this voltage is just VOD divided by A, right? Okay? Because my A is small, because of this R2, my A becomes, the voltage gain becomes very small, right? So this is not zero at all, right? Because A is small, I have a pretty large gain error. So, I cannot write it like that. So there should be something like 1 plus 1 over A or something like that. Something like, there is some gain error term, okay? Gain error. So also this gain error is depends on signal amplitude. It may cause some distortions also. All right. So if arrow is pretty large, you say there is some GM, BID, something like that, right? Yeah, arrow is pretty large. However, this current flows through this R2, right? Yeah, my gain will drop, okay? Question? Question welcomed. Any question? Okay, so let's so if I use capacitors, what happens? I use a capacitor, okay, instead of a resistor. Then my low frequency gain is pretty large, okay? Because at the low frequency, say, this is infinite. Capacitor is infinite, right? So let's just see. However, I need DC bias because C1, C2, there is no DC bias, right? I need a DC bias for this circuit. See, for DC biasing, I need a resistor. This can be pretty large resistor here. In a switched capacitor circuit, this 10 mega ohm resistor can be replaced by switches. In that case, see, I have a DC bias for input voltage, right? Yeah, those output DC bias voltage will be managed by CMFB circuit. CMFB circuit will generate output common mode voltage to 1.65 volt, right? This is the role of CMFB circuit. So I just apply DC bias at the input. It will be good enough, okay? Yeah, let's assume this 10 mega ohm resistor is very large compared to C1. So I just neglect the current through 10 mega ohm resistor. Also, if I assume my voltage gain A is pretty large, very large, then this offset voltage, this VOS is this voltage, right? This offset voltage is very small. This offset voltage is actually output. This is my output voltage, right? Differential output voltage divided by voltage gain, close to 0. Then I can neglect the current through this 10 mega ohm resistors, 20 mega ohm resistors, okay? Okay, then what's the voltage gain in this case? See, I apply a different AC differential input voltage. This not DC, AC. This is AC. Then current through this C1 must go through there, right? See, there will be something like the same current will flow through there, right? Yeah. So, yeah, I can say virtual ground. Assume virtual ground. My offset voltage is 0. Input offset voltage is 0. Then, yeah, then see, let's just see. I can calculate I1, right? By KVL. I apply KVL through this loop. Okay, so my VID equal, this is I1 times 1 over SC1, right? Plus another I1 times 1 over SC1, okay? Oh, I can calculate the I1. So my I1 is, this is 2, 1/2 SC1 times VID. Okay? Then I will apply KCL in the outer loop. See, let me see. So, yeah, my output BOD is this one, BOS is a 0, right? So by applying KVL around that loop, I can calculate BOD, which is SC2I1 minus BOS. Actually, this is a 0. Well, here, there should be another BOS, right? Should be BOS. This BOS is set to 0. Okay. And then SC2I1, right? So this is SC2 twice I1, which if I substitute this one in this I1, then this is C1, C2 BID. Okay? My output voltage is C1 divided by C2 times VID. Okay? Question? Question? 정경원 question?
잘 모르고 듣는데 VOS가 A 분의 VOD를 오픈루프에서 오프셋이 있을 때 VOD가 나타나는 거지 않습니까? 아웃셋 그러면 저기 이제 클로즈 루프에서는 VOS가 바로 VOD로 가지 않나요?
Okay, there is a confusion about the VOS. So there are some confusion. Okay, so I have my amplifier. If this amplifier is located inside a negative feedback circuit, okay, negative feedback circuit, then the let's just say this is a VOS, this is VOD. Yes, if I plot VOD with respect to VOS, then it should look like that. Okay, this can be the VDD minus VSS, VSS minus VDD. Okay, so actually this is this doesn't require negative feedback circuit. If this is this circuit is located in a negative feedback loop, it works in this region. Okay, with a negative feedback circuit. Okay, so this region is nothing but VOD equal voltage gain times VOS. Okay. So we apply the negative feedback there, right? We apply the negative feedback, okay? Then it should satisfy this equation, okay? All right? Okay.
저 R1, R2로 저항할 때는 저기 아웃풋 저항이 만약에 크면은 오프셋이 이거 때문에 제일 이상한 동작을 생기는데 만약에 이쪽에 그 버퍼가 여기 아웃풋 쪽에 뭐 버퍼나 이런 커먼드레이팅 버퍼가 되면 그렇게 했을 때는 그러면은 이거는 좀 없어질 수 있는데 그거랑 이 스위칭 캐패시터랑 그 차이가 있나요?
Okay, so your question is if I use a output buffer, something like it may be two stage. This is a buffer, unity gain buffer in this op-amp. Then yeah, I can just use a resistor because my output resistance is pretty small, right? But this can generate some additional gain additional stage, right? We don't like it. This unity gain buffer. Then yeah, I need a capacitor. This capacitor or switch the capacitor. Okay, switched capacitor works like a resistor. The switched capacitor is fine, even with a high RO. All right? Now, we don't want to add this unity gain buffer to drive resistance. Yeah, because there is an alternative way, right? We can use just capacitor, switch the capacitor without this unity gain buffer, right? So we usually don't use unity gain buffer in fully differential amplifier. Yeah, instead we use just a capacitor load instead of resistor load. Okay. All right. Yeah, let's go to the more realistic one. So this part is for DC biasing. Say I have this is 1 pop. This is 0.1 pop. So my voltage gain is with the feedback is 10. Yeah, this differential output voltage is 10 times this differential input voltage. So this one, this 5 millivolt 1 kilohertz sine wave. Say this is 5 millivolt times sine 2 pi 1 kilohertz, okay? T. Yeah, there is a differential. This is positive. There is a negative. This one is, let's just see, this is differential plus minus, differential 100 millivolt, differential 200 millivolt. This is 10K, 10 kilohertz. So those 1 kilohertz signal models equivalent input noise voltage of this op amp, okay? So you want to watch the effect of this equivalent input noise voltage. 네.
여기서 이거는 이제 이해했는데 만약에 저 서킷에서 보면은 이제 VOS에 있는 저 인풋 부분의 전류는 0이지 않습니까? 그 오피앰프의.
Oh yeah, this is 0.
그러면은 아웃풋 응당 VOS가 되어야 전류가.
Yeah, should be, but that's a trivial circuit, right? We use this one. Okay.
근데 만약에 여기서 인풋이 없으면은 그렇게 생각해도 되지 않나요? 오프셋만 딱 고려했을 때.
Oh yeah, sure. So the question is, if I don't have this C1, this C1 is 0, what happens? Yeah, should be my VOD should be minus VOS or something like that, right? Yeah, this case, yeah, it's located here, right? In this case, say because let's just say, yeah, this yellow curve represents the operation of this fully differential amplifier, right? And there is another constraint. See, this constraint is this is 0 volt, right? Because the current is 0, this C2 capacitor voltage is 0, right? So there is another constraint is my BOD equal minus BOS, right? There is another constraint here. This curve, okay? So my output voltage should be located here. We should satisfy this condition, okay? Yeah, if I have C1, there is another constraint, say something like that. Okay, or maybe something like that. I'm not sure. It depends on input voltage, okay? Yeah. So in a negative feedback, it's located in this region. Okay? Yeah. So we should satisfy this equation with a negative feedback. Okay, so let's just see. I apply 10 kilohertz input signal here, so I expect my output voltage differential output voltage is around, say, this is 200 volt. So 2 volt, is it 2 volt? Yeah. Sine 2 pi 10 kT plus. Yeah, this 5 millivolt noise, actually differential 10 millivolt noise, right? 10 millivolt noise. 10 millivolt noise will be amplified, right? Amplified by the voltage gain. Okay. Yeah, it depends. It may this voltage gain may depend on this C2, something like that. It has something like J 2 pi 1000 T. So my differential output voltage is a sum of signal component, 10 kilohertz, and noise component. Okay. Yeah. So SPICE netlist. This is a SPICE netlist. Yeah, you can find the same circuit here, and then where is my output? Oh, is this output? Oh no. Oh, let's try to simulate it.